In this video, you're going to learn about ellipses, and this is going to be a complete guide. So we're going to go through 5 examples together talking about how to graph ellipses, how to write the equation, how to find the eccentricity, and a lot more. So let's dive into this video. The first thing you want to understand is, what exactly is an ellipse? Well, we know it has kind of that ovalish shape, but more precisely in mathematics, what an ellipse is, it's the set of all points such that if you take a point on this ellipse, let's just call that point P, and we have these 2 points here, we'll call them the focus 1 and focus number 2. It's like you're taking a string and you're holding down the ends of the string, okay, like this, and you're putting your pencil or pen right here and you're pulling that string. Now the string doesn't stretch, so what happens is, it traces out this oval or elliptical shape. And the distance of this string, or the length of this string, is 2a. It's always a constant. And what you'll notice is, as this point moves along this ellipse, say for example right here, this string goes like this, and then it kind of wraps back around here. Now if you were to cut off this little piece right here and put it over here, that gives us the length of this longer axis, which we call the major axis. And that length there is called 2a. So let's just draw that on our diagram here. So the distance from the center to these vertices, these points along our major axis, that distance from the center to the vertex, that distance is a. And then the distance from the center to this co-vertex, or sometimes referred to as a minor vertex, that's this narrow direction, that distance we call b. And then the distance from the center to either of these foci points, that distance we call c. And all those a, b, and c quantities are related by this equation here, c squared equals a squared minus b squared. Now I know I'm throwing a lot at you right early on in this video, but you'll see how this works. When you work with these equations of an ellipse, the a squared and b squared determine whether the ellipse is going to be longer in the horizontal direction or longer in this vertical direction like this. And I'll show you how that works. So let's take a look at an example, and we'll discuss this in a little bit more detail. So say, for example, we want to graph this equation here, x squared over 25 plus y squared over 16 equals 1. You'll notice that the center of the ellipse here is at h comma k. That's like a shift or a transformation. But since we don't have an h or a k value here grouped with the x and the y, that tells us that the center of the ellipse is at the origin, or the 0, 0 point. So let's just go ahead and label that 0, 0 for the center. Now notice these denominators. See how the denominator underneath the x is larger than the number underneath the y? That tells us that this ellipse is going to be longer in the x direction, or the horizontal direction. And what we do is we take the square root of 25 to find a, which, remember, a is the distance from the center to the vertex, and that's going to come out to 5. So what I'm going to do is I'm going to go right 5, 1, 2, 3, 4, 5. That's one vertex. Go left 5, 1, 2, 3, 4, 5. That's our other vertex. And the number underneath the y gives us the vertical direction, or the distance here in this other direction, which in this case is going to be plus or minus 4. So I'm going to go up 4, put a point, and down 4, and put a point. And we can sketch our ellipse. Again, keep in mind, a is from the center to the vertex, b is the distance from the center to the co-vertex or minor vertex. Remember, the longer axis is called the major axis, the narrower axis is called our minor axis. The other thing we want to find out are, where are these foci? Where are these 2 points where we hold down the end of that string that traces out that ellipse? Again, we use this formula, c squared equals a squared minus b squared. It kind of looks like the Pythagorean theorem, but a little bit different. And what we do here is we say, okay, c is the distance from the center to the focus. We know that a squared is the larger denominator. That's going to be 25, minus b squared is the smaller denominator, 16. And that comes out to c squared equals 9. Take the square root of both sides, and we get c equals plus or minus 3. Now notice that the foci are on the same axis that the vertices are on. That's called our major axis. So I'm going to go right 3. That's our focus. And left 3, that's our other focus. And we've got a pretty good sketch of our ellipse. Now the other thing that we want to pay attention to is something called the eccentricity. Okay, eccentric, like how round is this ellipse, or how maybe outer round is it? And the eccentricity is defined as c divided by a. So c came out to 3, A came out to 5. And so our eccentricity is 3/5. Now the eccentricity for ellipses will always be between 0 and 1. The closer you get to 0, this is easy to remember, the more the ellipse looks like a 0, like a perfect circle. The closer that it gets to 1, the narrower it is, okay, and the more that it kind of looks like the number 1, either like this or like this, kind of stretched out. It's more eccentric, you could say. Let's take a look at another example. Okay, let's take a look at example number 2 now. We have x minus 1, the quantity squared over 4, plus y plus 2, the quantity squared over 9 is equal to 1. First thing we want to do is we want to find the center of this ellipse, and that's going to be our h comma k value. Now notice that this is minus 1, but that means it's actually going to shift the graph right 1. So it has like the opposite effect. Same thing here, the plus 2, it's actually going to shift it negative 2 or down 2. So our center here is going to be at 1 comma negative 2. Just remember it's the opposite sign. So let's go ahead and locate that on our graph here. Right here is our center. Now, the thing we want to pay attention to is which denominator is larger. That's going to determine what our a squared value is. So here you can see that this denominator is larger. So a squared is going to be equal to 9. And because that larger number is underneath the y variable, that tells us it's going to be longer in the y direction. Okay, so this is going to have what we say a vertical major axis. Okay, the major axis is in the vertical direction. The minor axis would be in the horizontal or the x direction. So what I'm going to do, this is our a squared. Okay, like this equation here. I'm going to take the square root of 9, which is 3, and I'm going to go in the y direction, up 3 from the center and down 3 from the center. And those are going to be our vertices. What you can do also is you can just, from the center, just go ahead and add and subtract the a value here. So this is going to be, vertices are at negative 2 plus 3, which is 1, or negative 2 minus 3, which is negative 5. Okay, now let's go ahead and find our minor vertices or our co-vertices. That's in the narrower direction, and this is going to be the square root of 4, which is 2. So from the center, I'm going to go right 2 and left 2 in that x direction. Those are our vertices or co-vertices. So we have a rough sketch, okay, of our ellipse. We now want to find our foci. Remember, those are the points that we're holding down and pulling that string, right? Traces out that ellipse. And the foci are always going to be on that major axis or that longer axis. We use the formula c squared equals a squared minus b squared. Keep in mind this is our a squared, the larger denominator. This is our b squared, the smaller denominator. So we've got c squared is equal to a squared minus b squared, which is equal to 9 minus 4. And if we take the square root of both sides, we get c equals plus or minus the square root of 5. So what I'm going to do from the center, which is 1, negative 2, I'm going to add and subtract the square root of 5 from the y coordinate because we're going up and down. And this will give us an exact location of our foci. Now, if you just want to get a rough sketch on your graph, square root of 5 is about like 2.2. You could go up 2.2 from the center, down 2.2 from the center, and roughly plot where those foci are. But this will give you an exact location here. Now let's take a look at the eccentricity. How eccentric or out around is this ellipse? And that's going to be our formula c over a. C we figured out was square root of 5. You can just take the positive one. You don't have to do the plus or minus, just the positive value. And then the a was the square root of 9, which is 3. And if you were comparing two ellipses, you could kind of get a sense of which one was rounder and which one was more stretched out or eccentric. It just gives us a little bit of an indication again of the shape of the ellipse. Let's take a look at another example. Okay, in example number 3 now, we're going to shift gears and talk about writing equations, given some information. So say, for example, we're given the vertices of the ellipse, which are at 2, negative 3, and 6, negative 3, and the foci are at these 2 points. How do we get the equation? First thing I like to do is sketch a graph that'll kind of help us to visualize what this ellipse looks like. So vertices at 2, negative 3 would put us right here. V for vertex, 6, negative 3, 3, 4, 5, 6, right about here. And foci at 3, negative 3, and 5, negative 3. Okay, so we can see our ellipse looks something like this, right? Now keep in mind that the center of the ellipse is going to be halfway between the foci, halfway between the vertices, halfway between the co-vertices. So we can use any two of those points to find the midpoint. And remember, the midpoint, it's the average of the x's and the average of the y's, meaning you add up the two x coordinates, divide by 2, you add up the two y coordinates, divide by 2. So let's do that. 6 plus 2 is 8, divided by 2 is 4. Negative 3 plus negative 3 is negative 6, divided by 2 is negative 3. And you can see here that our center is at 4, negative 3. Now, sometimes you can just count and find that midpoint, just kind of, count to the middle. But the midpoint formula comes in handy here. Okay, now, notice what we're given. We're given the distance from the center to the focus, which, let's see, that's 4 to 5. That's a distance of 1. So the distance from the center to the focus, we say that distance is c. So we know that c is equal to 1. The distance from the center to the vertex, let's see, that's from 4 to 6, that's 2. So we know that our a value is 2. And b is the distance from the center to the co-vertex or minor vertex. Okay, depending on the book, it's called by different names. But let's see if we can figure out what b is by using this formula, c squared is equal to a squared minus b squared. C squared would be 1 squared, which is 1. A squared, which is 2 squared, which is 4. And if we solve for b squared, let's see, subtract 4, we get negative 3 equals negative b squared. Multiply both sides by negative 1, you can see b squared is equal to 3, which means that b equals the square root of 3. Square root of 3 is about 1.7, so from the center we would go up about 1.7, down 1.7, and we could get like a rough sketch of our graph. But the main thing we're interested in here is the equation of the ellipse. So let's start putting that together here. So it looks like this is going to be x minus the x coordinate of the center squared plus y minus the y coordinate of the center squared. Remember, when you subtract a negative, that's like adding the opposite. So notice these are the opposite signs here. Equals 1. Ellipses always equal 1. We have to figure out what our denominators are. And notice that it's longer in the horizontal direction or the x direction. That's going to be our major axis. And you can see that distance from the center to the vertex was 2. 2 squared is 4. So you can see it's going to be in this top form here. 4 is going to go underneath the x. That's our horizontal direction. The square root of 3, that's this b value, the distance from the center to the co-vertex or minor vertex. When you square root of 3, b squared is equal to just 3. And that's the equation of our ellipse. Let's take a look at another example. Okay, in example number 4, we're also writing an equation, but we're given different pieces of information. We're given the foci and the minor axis of length 4. How do we find the equation? Well, I always like to draw a sketch just to help me visualize and put together, what this ellipse is looking like. So we've got negative 4, 2. So that's one of our foci. And we have negative 4, 10. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right about here. That's our other foci. And a minor axis of length 4. Now remember, the foci are on the longer axis, the major axis, which means this ellipse is going to be kind of like elongated in this vertical direction. And the center is halfway between the foci. So what you can do is you can use your midpoint formula, negative 4 plus negative 4 divided by 2, which would be negative 4. And 2 plus 10 is 12, divided by 2 is 6. So it's just like an average. You add the x's and divide by 2, add the y's, divide by 2. And that's going to put us right here at negative 4, 6 for our center. So what I might start to do is start writing the equation x plus 4 squared plus y minus 6 squared equals 1. We just have to figure out what the denominators are, the a squared and b squared, right? And look at what we're given. We're given the distance from the center to the foci. So from negative 4, 6 to negative 4, 2, that's a distance of 4 units. The distance from the center to the focus is our c value, okay, which is 4. The distance from the center to the co-vertices, that's our b value. And because our minor axis has a length of 4, I could go from the center, I could go right 2, which is right about here, and left 2, which is right about here. And so that tells us that b is equal to 2. We just need to figure out what a is. And remember, this equation, c squared equals a squared minus b squared, relates the a, b, and c values together. So we have, let's see, c squared equals a squared minus b squared. C squared with 4 squared is 16. A squared we don't know. B squared, 2 squared is 4. If I add 4 to both sides, a squared is equal to 20. And if I take the square root of both sides, that would mean that a equals the square root of 20, which is about somewhere in between 4 and 5, right? So maybe around 4.5 roughly. So that means from the center here, we would be going up, let's see, 1, 2, 3, 4.5. So our vertex would be right about there. And then down 4.5, which would be somewhere right about here. So we can see our ellipse looks something like that, okay? And we know that a squared, see, it's longer in this vertical direction, this y direction. That a squared is going to go underneath the y, which is 20. B squared, which is 2 squared, that's 4. That goes underneath the x. That's our horizontal direction, okay? That's our x direction. And now we've got our equation of our ellipse. Let's take a look at one last example. For this last example, we're going to talk about completing the square and putting this ellipse into the standard form of the equation of ellipse. And then we're going to graph it and talk about the eccentricity, etc. But before I do that, I just want to let you know that if you enjoy the way that I explain things and you want to go deeper with some of these topics, I've got an Algebra 1 and an Algebra 2 video course for sale. I'll put links in the description below. So if you need help reviewing those courses, check out those video courses for sale. And if you just want to support the channel, you can join as a channel member for a few dollars a month, and it helps support the content that I put out here on YouTube. And then lastly, if you just want to go deeper in learning about any of these topics, I've got now over 1,000 videos on my Mario's Math Tutoring YouTube channel. So subscribe to the channel, check out those videos, and I look forward to helping you further with your math. But let's get into this last example. So pretty exciting here. We've got this equation, but it's kind of a jumbled mess. And so what we're going to do is we're going to group the x's together. I'm going to group the y's together. I'm going to add the constant to the other side of the equation. So if I add 11 to both sides, this is going to become positive 11. Okay, that's step number 1. Step number 2, we want to divide out this leading coefficient. So in this group here, the x's, I'm going to factor out or divide out this 9. So that's going to leave us with x squared minus 2x. Here I'm going to divide out or factor out this 4, just the leading coefficient, not the greatest common factor. And then what you want to do is leave a little space for completing the square. And the way we complete the square is we take half of this b value, this coefficient in front of the y or x term. Okay, we take half of it and we square it. So you can think of it as b divided by 2, the quantity squared. So negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. Out of thin air, I'm adding 1, but because it's in parentheses, it's actually 9 times 1. I'm actually adding 9 to the left side of the equation. So to keep it balanced, let's add 9 to the right. Okay. Same thing over here. Half of 4 is 2. 2 squared is 4, but it's actually 4 times 4, 16 that we're adding to the left side. So to keep this balanced, let's add 16 to the right side. Now what we're going to do is we're going to factor what's in parentheses here, and it factors to a binomial squared. So it's always going to be half of this b value, x minus 1, the quantity squared. If this was plus 2x, it would be plus 1. Same thing over here. We've got half of 4 is 2, so this is going to be y plus 2, the quantity squared, equals 36. Now remember, ellipses, we always want these to equal 1. So to get this equal to 1, let's divide everything by 36. And let's reduce. So 9 goes in here once, 9 goes in here 4 times, 4 goes in here once, 4 goes in here 9 times, and this equals 1. So our final equation here looks like this: x minus 1 squared over 4 plus y plus 2 squared over 9 is equal to 1. Okay, so we've got it in the standard form of the equation of ellipse, but how do we get a sketch of this now? Let's see if we can graph it. And first thing we want to do is find the center. So we have 1, negative 2 as our center, right there. Let's go ahead and label that 1, negative 2. It's going to be longer in which direction? The x direction or the y direction? Y direction, because this denominator is larger, so it's going to be stretched in that vertical direction. Square root of 9 is 3, so we're going to go up 3 from the center. That's our vertex. Down 3 from the center. That's our other vertex. Let's label those. So that's going to be 1, 1, and 1, negative 5. And then, let's see, in the x direction, we're going to be going square root of 4, which is 2. So right 2 and left 2. Those are our co-vertices or minor vertices. We can get a rough sketch of that ellipse. If we want to find the foci are always on the major axis, the longer axis. So remember the formula, c squared is equal to a squared minus b squared. C is the distance from the center to the focus, which we don't know. A is the distance from the center to the vertex, which we said was square root of 9, which is 3. So 3 squared is 9. B squared is 4. So we have c squared is equal to 5. C equals plus or minus square root of 5. So from the center, our foci, it's going to be negative 2 plus or minus square root of 5. So up and down, square root of 5. And if we want to find the eccentricity, we use the formula c over a. That's going to be square root of 5 over a, which we said was 3. And that gives us an idea about how round or how out of round this ellipse is. So great job. If you want to learn more about these conic sections like ellipses and parabolas and hyperbolas and circles, I'll put a comprehensive video I did right there going through all those different conic sections. Follow me over to that video and we'll get some more practice. I'll see you there.